All right, welcome back, everybody. This is episode 3 of my Elisity Cognitive Trust series. And in this episode, we're going to be doing a medical device and user security demo. This time, I invited my colleague and my technical marketing engineer, Taylor Caldwell. He'll be doing the demo. I'll start with a little overview of what we're going to be doing and what we're looking at so that we're all on the same page, and then we'll jump into the demo. Let's get started. Before we jump into the demo, I want to quickly touch on the identity engine that we built here at Elisity. From the beginning, Elisity has been focused on bringing to the market a solution that's completely brownfield ready and non-disruptive. That includes the robust identity engine as well as the policy enforcement component of our platform. The identity engine allows us to dynamically discover devices, users, and applications on the network. And it doesn't matter what type of network you're on. It could be a medical environment, it could be an operational technologies environment, process control network, or just your standard corporate environment. It really doesn't matter. And it also doesn't matter what types of devices, users, and applications you're running on the network. Elisity is completely agnostic to all of that. We run on top of your existing environment, and that's what allows us to be completely non-disruptive. Now, we don't make any changes to the access ports. We're not playing with MAB, we're not adjusting 802.1x configurations. There's no user agents or supplement requirements. And we're independent of the VLANs and VRFs and network topology or physical architecture that you're already using. We don't manipulate any of that. So this allows us to be 100% non-disruptive. And I love this because it makes us so easy to integrate into any type of network. We can deploy our solution and reach the time to value extremely rapidly. Now, while Elicity's identification engine is great and can be completely standalone, we also integrate with third-party industry-specific identification engines such as Medigate, Claroty, and many others. And that's what we're going to talk about today. So the next set of slides, I'm going to jump into our Medigate integration. At a high level, here's how the integration works. At the cloud layer, we have Elicity's Cloud Control Center. This is our cloud delivered and cloud native control plane, management plane, and policy plane. There's also Medigate's cloud analysis server. On-prem, Elisity has deployed Elisity software running as a container on application hosting supported switches such as the 9Ks, or as a virtual appliance to onboard switches that don't support application hosting. From the Medigate perspective, there's a collection server that's collecting data as well, so that this data can be packaged up and sent up to the Medigate cloud server for additional analysis. Let's run through it step by step. When a device shows up on the network, both Elisity and Medigate are simultaneously doing the identification process. Elisity is collecting metadata about that device and sending it up to Cloud Control Center. Medigate is doing the exact same thing with their collection server and sending it up to their analysis server in the cloud. Once this analysis is complete, Cloud Control Center will query Medigate via an API connection to enrich our asset inventory with additional attributes that Medigate learned that we didn't. So now these new attributes are learned in our asset inventory, and you can use these attributes as match criteria in a Elisity policy. Now, if a policy was already created, well, it's as simple as the system matching that device to the policy and a policy being pushed to the edge of your network and being enforced immediately. Or you can go in and create a policy after the fact, and the same process will occur. It's really as simple as that. So I'm going to hand it over to Taylor so he can show you in real life what this looks like. Taylor?
Thanks, Dana. So as you mentioned, we are leveraging our connector with Medigate to enrich data about medical devices in our network. So let's take a look at a couple of these devices in our device dashboard. So in Cloud Control Center, we're in the device dashboard here. Let's filter by IoMT devices or medical devices on our network. So here's a list of 4 medical devices that we've discovered on our Elisity secured network, and then our connection with Medigate has enriched this data with things like model, operating system, vendor. And if we click on one of these devices, like this CT scanner, for example, we can see all the data we've gleaned here. So for example, we have device class, device type, the genre and the model, even the policy enforcement node, which the device is connected behind. And we can use all of these criteria about this device to match it to a policy group. Most importantly, we can see this device's list of policies here. So we have, about 7 or 8 policies that determine what this device is allowed to communicate with on the network, or what traffic flows are allowed. Now let's go over to our user dashboard and look at one of our users that we're going to be demonstrating. So here in our user dashboard, we can find all the data we've gleaned about all of the users that we've imported via our connector to Active Directory. In this case, we can see our policy groups, we can see our IP addresses of the user's device, and we can customize this column to see whatever is most relevant, whatever we want to see as an administrator. Let's focus in on our user Olivia Douglas. This is the user that we're going to be demonstrating with. We can see she's a member of the Active Directory group Radiologists, and therefore she has a policy group, Radiologist, that is matched based on her identity as a radiologist in Active Directory. So she has a list of policies as well. So again, we can see some of the data that we can match on for Olivia and use that to assign her to a policy group. Now, with all this data we've gleaned about users and assets, we needed a place to easily deploy policies and use this data. So we came up with this policy matrix, and this is where we create and deploy policy groups that are then referenceable in this really nice graphical view. So for example, let's filter by radiologist because our user, Olivia, is a member of that group. So here we can see all of the policies we've deployed for the radiologist Active Directory group. We have policies for printers, media servers, for these smart plug IoT devices we have on our network. Most importantly though, we have policies that permit access to the electronic health record servers and the imaging devices on our network, but only on specific protocols. Let's take a look at this radiologist to electronic health record server policy. So after clicking on this policy, we can see our source and destination, and in more detail we can see we're matching on her Active Directory group as well as her company information as Elisity here. And then for the destination, electronic health record server, we're matching on device type EHR. And if we click details on both of these, we can see exactly the devices and users that are matching. Here we can also see the security profile rules. So we are only allowing port 8042. This is the port that users need to access the web interface for this electronic health record server. And we're denying all other traffic between these two groups. The end goal is to only allow Olivia to access these devices on the ports and protocols that are required to do her job. Now let's look at device-to-device policies. We have 2 devices we're going to demonstrate here. We have an EHR server and we have a CT scanner, which is classified in the imaging devices policy group. Let's look at this policy. So here you can see in the source we're matching on CT scanners and MRI devices in this imaging devices policy group. We can see the devices that match this criteria, and that includes the CT scanner that we looked at earlier. For our destination, we have the electronic health record server that we had mentioned. And our security profile rules in this case only allow these 2 devices to talk on DICOM protocol, and all other traffic is denied. So we have port 4242 here and port 104. These are the DICOM protocols, and all other traffic is denied. The end goal here is similar to the end goal with our user policy. We only want these 2 devices to communicate on ports and protocols that allow them to function for their intended purposes. Let's look at some of these policies in action. So let's move over to our user's demo PC. So here we are on our user Olivia's PC, and we have an application running that shows access to various devices on the network, like our printer and our electronic health record server and our CT scanner. Let's leverage our access to a couple of these devices. So let's start a session to our CT scanner. We'll start a remote desktop session. So here's the workstation for our CT scanner. We have an anonymized patient record that we want to transfer to the electronic health record server using the policies that we created that allow DICOM protocol. Let's go ahead and initiate this transfer. We'll click copy to health record server, and we'll see our status bar that indicates a successful file transfer. So we finished transferring this record. Let's move over to the electronic health record server and view this health record there. So we have to sign in here. We'll sign in and we'll view this patient record. We'll click all patients, and here's our anonymized patient record. Let's view this CT scan of this abdomen just for fun. So we can see all 33 images that were contained in this health record are present and accounted for. But say we didn't want this CT scanner workstation to be able to transfer to this specific health record server. Well, we can deny that traffic as well. Let's move over and modify this policy that we created earlier. So the two custom TCP rules that allow DICOM traffic, we're simply going to change from allow to deny. And as we deploy this, the policy will be pushed in real time within 5 to 10 seconds. And if we move back over to our workstation for the CT scanner on our user's machine and we reinitiate this transfer, we'll see that this transfer fails.
Awesome, Taylor. So the key here I want to point out is that this was completely done via identity. Nowhere did you mention or refer to VLANs or IP addresses or MACs or any of that. It's all based off of the identity of the user and the AD group that she's a part of, as well as the identity of the device.
Yeah, exactly. That's the power of the solution. So what we're really trying to drive home here is securing specific medical protocols and healthcare protocols from only desired sources. We only want this server to talk to this device. We only want this CT scanner to be able to transfer to this server. We can do this with a variety of devices and a variety of protocols in a number of industries. But device-to-device identification and policy enforcement is only one part of the solution. We also have the identity piece for users. Let's look at what happens when we change our user's identity. So currently Olivia's a radiologist, but let's say she is a contractor that was working on our CT scanner to test and fix an issue with the CT scanner. We wouldn't want that contractor to have access to anything on our network besides this specific device. So let's change our user's identity in Active Directory, and then we'll see that network access change. So we're changing our user from radiologist, like we had mentioned, to medical contractors, just another Active Directory group. But we're auditing this change in Active Directory in real time. And when this change is pushed to Cloud Control Center, this user's identity will change in Cloud Control Center, meaning she'll be a member of a new policy group with a new set of policies. So we've applied this change, and let's go over to our user's device and open our application that shows network access. So we can see in a matter of seconds, our user's network access has changed, and now she only has access to the CT scanner that we want her to work on.
That's very cool. She now doesn't have access to the EHR server because that could be a HIPAA compliance issue, right? She should only be able to maintain or do maintenance on the CT scanner itself and nothing else that the CT scanner has connections to.
Exactly, Dana. So if we move back over to our web browser, we're going to see our user lost access to the EHR server. So we can see the session that was existing is cached, and she no longer has access to this server. So we're really helping customers meet that HIPAA compliance. Next, let's look at Cloud Control Center. So we had mentioned her identity changes there, and we can see that. We can see her Active Directory group is now medical contractors, what we had changed it to in Active Directory. And we can see she has a new set of policies that are very restrictive, only allowing access to the imaging devices on the network.
Awesome work, Taylor. This demo truly showcased how simple Elisity has made it to implement least privileged access architectures and identity-based microsegmentation policies across your entire infrastructure edge.
Yeah, Dana, it really makes building policies a breeze. And you'll notice I didn't have to sign out and sign back in for these policy changes to take place.
It's immediate, right?
Right.
All right, man. Thank you for your time. I'll see you in the next one.
See you, buddy.